3, 2, 1, let's go. Hi everybody, and welcome to another exciting edition of Boring JavaScript. I'm your host, the Virtuoid, aka Mike Smith, and today we're going to be talking about the reduce method on arrays. Now, what does reduce do? Well, it performs a reducer function on each and every element of the array, resulting in a single value. Now, what's a reducer function? Well, the easiest way to tell you about it is to show you how it works. So, why waste any more time? Let's go ahead and get started. So let's take a look at the reduce method. Well, here it is. First thing you'll notice that it has to be on an array. So here's the array. I've got an array of just 7 numbers, no biggie there. The reduce method takes 2 arguments, the reducer function and an initial value. Now, the initial value is optional, and I'll show you why here shortly later on the video. But the thing I want to really concentrate on here on this part of the video is the reducer method. Now, the reducer method, or function, excuse me, looks something like this. Now, the idea here is that you are going to be given what's known as an accumulator and a current value. And this current value will be the value of each element as JavaScript goes through each of the different elements of the array. So current values will be 34, 19, 22, 99, 44, 33, and 19. Your job within the body of the reducer function is to return some sort of value based upon the current value, or some sort of relationship between the current value and the accumulator. And in this case, I'm going to add in the accumulator and the current value together and return that. Now, here's the important thing. The value that is returned into the accumulator, and JavaScript remembers from one element to another the value of accumulator. So the first time through here, accumulator happens to be 0, and the current value is going to be 34. So when we add them together, we're going to end up with returning the value of 34. Well, from JavaScript's point of view, 34 will now become the accumulator for the next element. So the next element, which happens to be 19, accumulator is going to be 34, and current value will be 19. So we add those two together, we'll end up with 53. So the third time through on the array, current value is going to be 12, and the accumulator will be 53. So as you can tell here, the accumulator is remembered by JavaScript each and every single time that element is being parsed to do something. And your job, again, like I said before, within the body of the reducer function is to be able to return some sort of value. When all is said and done, that final accumulator value is what gets returned back to JavaScript, or back to your application. So when all is said and done, I should expect final number here to be the addition of all of these different elements here. And this little for each loop I've got right here just kind of helps me check or double check to make sure that I've done everything correctly. So I should have final number equal out to number check. So again, the reducer function, the whole purpose of it is for you to be able to tell JavaScript what that accumulator value is going to be, so that the next time JavaScript goes through each one of these elements, it will pass that accumulator value to that very next element. The final result being that the accumulator value will be a reduction, and that's where the word comes from, a reduction of all of the different elements within the array. Want to see how it works? Let's take a quick look. Let's flip over to Node and type in node reduce. The final number is 261, and it should be 261. So it worked. So this proves that my reducer function started out and added all of these numbers together one at a time, passing that accumulator number through each of the elements. Now, the next thing I want to show you is I want to go down into details of exactly what's happening within that reducer function. Now, the next thing I want to show you is exactly the internals of what's going on within that reducer function. And I think by showing that, it will help you understand what you need to do if you ever want to write your own reducer function. So let's go into the code here, and I just so happen to have some code written down here that replaces my reducer function. So let's go back up here, let's paste that, and let's see now what's happening. So what I'm doing now is I've now got 3 arguments that's being passed my reducer function. The accumulator, the current value, and a new one called index. Now, in actuality, there's 4 of them. The 4th one is the array itself, and I'm not using that in this example. So what I've done now within the reducer function is I'm going to print out what the current index is, the current accumulator, and the current value. And this will kind of show you, as JavaScript goes through each of the different elements of the array, how that index is changing, how the current value is changing, and how the accumulator is changing. And just like before, where I just said I was going to return the accumulator plus current value, I'm doing the same thing here. As I'm returning the accumulator plus current value, so that the new accumulator, each time it goes through, will get changed, and in this case, incremented by the current value of the element. Other than that, everything else is exactly the same. So let's flip over to Node, and let's run it. Node reduce. A little bit more information here than before. Now, let me explain to you what's going on here. Remember, we had 7 different numbers here, but if you notice, we have 6 different indexes. So what has happened here? Well, this is something very important to remember, is that, remember earlier, and let's flip back to the code here. Earlier I said that the reduce method takes 2 arguments, a required reducer function and an optional initial value. Now, it's optional, so you don't have to specify it. And JavaScript operates in 2 different ways depending upon whether you specify an initial value or not. So let's flip back over to Node and take a look at what happened. Now, in this particular reducer method, I did not have an initial value. When an initial value is not present or is not there for JavaScript, what JavaScript will do is that it will automatically take the very first element of your array and make that the accumulated value. So the very first time through here, which is index number 0, we don't see an index number 0 because it automatically assumed, hey, you know, there's no initial value, so obviously the first instance, or the first, the first instance of my array should be the initial value. So sure enough, that's what happened here. Accumulator is now 34 because it took the first element as the initial value. And then it just went on from 19, 12, 99, 45, 33, and 19. And as you can tell here, as each of the indexes went up, 1, 2, through 6, the accumulator also went up. So the second time through, which is technically the first time through, we took 34 and added 19 together, and we got 53. So that when we got to the number 12, which is the third index value or the third element within the array, we're now taking the accumulator 53 and adding 12. That gave us 65, which means 65 was now passed to the next current value. That gave us 164, which means 164 was then passed to the next value, which was 45. That gave us 209, and so on and so forth until we got down to 261 on its own, 261 itself. So this shows you internally what's going on here. Again, since I did not put in there an initial value, accumulator automatically assumed that the 0 element, which is 34, automatically became the value for the accumulator, and it just went on straight from there. So what will happen if we do have an initial value? Well, let's flip back over to code and find out. So let's put an initial value of 10 inside there. And just for that number check, I'm also we'll make the number check also start at 10. So now I put an initial value of 10 inside there. So let's take a look and see what happens there. And I'm not going to clear the screen off like I normally do here. So let's just do that. Let's see if I can get both of these on the screen at the same time. Well, not quite, but I got the important part on the screen. Important. So here's the very beginning. Remember, this part was without the initial value. So JavaScript automatically assumed that the first element was the initial value. However, when we do an initial value, which happened to be 10, that accumulator automatically got set to 10, and so we had to start with index number 0. So if you have an initial value, then your reducer function is going to begin with the very first element, or the 0th element within your array. If you do not specify a initial value, then your 0th element is going to be assumed to be the accumulator, and you're going to start at index 1. And did our numbers come out correctly? Of course they did. Here's 271 and 271, which shows that by putting the number 10 there as the initial value, that gave us exactly what we needed. So just to recap, make sure you understand here. If you do not specify an initial value, your beginning accumulator number will be your very first element in your array. If you do specify an initial value, the accumulator value will be that initial value, and it will start indexing or start running the reducer function onto the index, on the 0 element itself. So that's how the reduce function works in general here. Now, Can it be used with just numbers? No, it can be used with anything. And so let me show you how you can use it with strings next. So that's how you can use reduce with an array of numbers. How about an array of strings? What can we do with that? Well, you can do a whole bunch of fun stuff with it. For instance, here is an array of animals that I have for the example here, and here is my reducer function. And the idea of this reducer function here is that if the animal's name, which is an animal here, starts with the letter C, I want to add 1 to the accumulator, otherwise I'm going to pass back the accumulator itself. And that way I'm just basically counting how all of the different animals that start with the letter C. So if you take a look at this, we have cat, which starts with the letter C, we have cow, which starts with the letter C, and coyote, which starts with the letter C. And so therefore, our final value here should be, we have 3 animals that start with the letter C. It's real simple, real quick. So this shows you a way that you can be able to use the reduce function with strings for this example. So let's flip back over to Node. Let's take a look at it, and let's go Node, what do you call it? Animals. I couldn't remember what I called the file name. So here we go. I have, ooh, what happened here? I have cat11 animals that start with the letter C. What could have gone wrong there? Let me show you exactly what went wrong there. We forgot a very basic tenet of using the reduce method, and that is that if we do not specify the starting number for the accumulator, or the starting value, the initial value for the accumulator, it will take the first element. So let's flip back over to our code and take a look at what we have here. So I did not specify an initial value, so accumulator will say, okay, or JavaScript, excuse me, will say, okay, I'm going to use the first element as the initial value. So what's the first element? It's cat. So the second time through, we went with the dog, no big deal, we returned cat. Third time through, we went with the horse, returned cat. Fourth time through, we got the cow. Well, cow started with C, so we're returning accumulator plus 1. Now remember, what's the value of accumulator? Cat. Because we didn't start initial value, it took the first element. So our value of accumulator is cat. We're adding 1 to it. In JavaScript, it just basically says, okay, well, I got cat as a string, 1, it's a number. Well, we'll convert it to a string and throw them together. Concatenate them together. Same thing happened with coyote here. So we end up with cat 1, 1. And that's exactly what we ended up with here on the node site, cat 1, 1. So this is one of the gotchas with using the accumulators here. If you have a mixed values within your arrays, you got to be absolutely certain that you understand or set that accumulator to the initial value that you want to set it to. So how do we fix this problem? Very easy. I'm going to set the initial accumulator to 0 because initially we have no animals that start with the letter C because we haven't gone through the array yet. And by doing that, accumulator is going to start with the number 0, hit cat, and it's going to add 1 to it for cat, add 1 for cow, and 1 for coyote. So now this should work fine. Let's flip back over to Node. Yep, it sure did. Look, I have 3 animals that start with the letter C. So that's one of the things you got to be very leery of with doing the reduce method here, or producing your reduce function, is that it's always a very good idea to try to deliver an initial value. So that way you're absolutely certain that your accumulator is going to have or start with the correct value. Because if you don't, it's just going to start with the first element. And if that first element just happens to be not of the value that you're looking for, all kinds of strange things could happen. So if you're going to use the reduce method on your arrays, make sure you start with an initial value and it will work great. Now, next thing that I'm going to show you is something absolutely fantastic. I'm going to show you how to create a class which has multiple extends, which is not possible in JavaScript, simply by using the reduce method. And that's next. Okay, so next I'm going to show you something about the reduce method that is just going to absolutely blow you away. And I learned this from somebody that I work with on my pay the mortgage job. All these videos don't pay the mortgage. I did this just for fun. And this is what it is. Here is something that you should all be familiar with here. I have a certain class that I've defined, and I've got a second class that I've defined here that has extended the base animal class. Real simple. This is relatively simple JavaScript. Now, what a lot of languages will allow you to do is to build a class to extend multiple classes. So, for instance, I may have had base animal, mammal class, hairy cat class, things like that. But to be able to extend multiple classes within another class. Now, that is something in JavaScript you cannot do. You can only do one at a time. Or can you? Now I'm going to show you something really interesting on how you can use the reduce method to be able to simulate extending multiple classes within the class. Okay, strap yourselves in. There's a lot of code to go through here. Here's what I'm going to be doing in general. I have now a function here that is a replacement for a class. And this function is going to return a new class definition that is going to be a combination of all of these other different classes. For instance, down below there, I have a function that returns a class for body, a function that returns a class for head, a function that returns a class for tail and for legs. And I'll show you that in here in just a minute. So this is going to be a function that will return a single class. Here is that function right here, and it uses the reduce method. First of all, I use the deconstruction operator to be able to take these individual parts and put them into a single array. And then I use the reduce function to be able to reduce all of those different functions from one or from a bunch of massive different classes into one single class. And I'm going to start with the class base animal. So my base animal is obviously my very base class. So base animal will become my first accumulator, because again, remember, I'm using the initial value here. So base animal is my accumulator. Here is my reducer function. And it's very simple. I've got my accumulator, which is I've called all animal parts, and I've got my current value, which is animal parts. So for instance, on cat here, I have 4 of them: body, head, tail, and legs. And so it's going to go through each one of those, and all I'm going to do here is I'm going to execute the animal part while passing the base function or the accumulator to it. And by returning that, it's going to accumulate all the different extents. And let's kind of show you let's go in details how this works. So base animal is my accumulator. So it's going to start with base animal. When it goes through the array the first time, body is going to be my first one here, and I'm going to execute the function body, which is that function right there. I'm going to execute the body function and pass to it base animal. Let's go down all the way down to body. Here is my body function, and all body function does is return a class, and that class is body extending the base. And as you can see here, the argument is the base. In this case, the base is going to be base animal. First one through here. Legs does the same thing. I've got a class called legs, and it returns the class called legs, and it also just extends base. Arms. If I pass the function arms, if I use the function arms, I'm going to pass to it a base class, and it's going to extend the base, and I'm going to return the arms. Same thing with head. I'm going to return head. It extends base. Same thing with tail. I'm going to return tail, and it extends base. Same thing with wings. I'm going to return wings, and it extends base. So as you can tell here, I've got a ton of different classes here, but I've wrapped each class inside of a function so that I can pass as a variable the extended class within that function. So I don't have it hard-coded class wings extends base animal or anything like that. It's now class wings extends whatever variable I happen to pass in the function. And by returning the class itself, I've basically have extended that class with whatever value I've passed within the argument. So let's flip back to the very beginning here, and let's go back to our reducer function. So all animal parts is my accumulator. Animal part is my current value. And I'm saying now, go to the current value function and pass the accumulator. So first time through, very first time through, and we're going to use cat here as example. First time through, base animal is my base class. I go to the body function, and I'm going to say execute body function using base animal as the variable. So let's go to body. Here's body, and I'm going to return class body extends base animal. That's what I'm returning. Let's go back up here the second time through. The accumulator now, remember, is body extends base animal. I now got head, and it's going to execute head with the body with head, which had extended the base animal. So let's go down to head. Wherever head is, up there's head. And head is going to extend the variable. And that variable, again, remember, is the body with the base animal extended. So when this executes, I'm not going to have the head, which has extended the body, which has extended the base animal. So you see what I'm doing here? I'm just kind of accumulating all of these different classes. Again, I can only do one class at a time, so I can't say extend a whole bunch of them, but I'm just slowly building everything up here. So if I go back to the top, the third time through, tail is going to come in here. So we're going to execute tail on our big, huge accumulated class. So tail, there it is. Tail extends base. So what's base? Base is head, which has extended body, which has extended all animals. So now I've got tail extends head, extends tail, extends head, extends body, extends base animal. Finally, it will go through and add legs to it so that once this goes through that section again, I'm not going to have legs, which extends tail, which extends head, which extends body, which extends base animal. So finally, all of that got passed here because that's the final value for your accumulator. So my final accumulated value is class cat extends legs, which extends tail, which extends head, which extends body, which extends base animal. Now, I have not really extended cat to extend all of those different classes, but what I have done is that I have basically built classes one on top of another, starting with base animal and adding to it body, then adding to that head, then adding to that tail, then adding to that legs to finally get my class. And then of course cats have 4 legs, so I popped in legs here. Same thing if I wanted to do a Roadrunner here. Roadrunner, I'm going to start with the, again, base animal, because that's what, because extender always starts with base animal. So Roadrunner is going to have base animal, body is going to extend base animal, head is going to extend body, which extends base animal, tail is going to extend head, which extended body, which extended base animal, legs is going to extend tail, which extended head, which extended body, which extended base animal, and finally wings is going to extend legs, which extended tail, which extended head, which extended body, which extended base animal, before I finally get the Roadrunner, which finally extended wings, which extended legs, which extended tail, which extended head, which extended body, which extended base animal, and I'm done at that point. And of course, Roadrunners have 2 legs and 2 wings. And so what I've done here now, I am initiating my cat, and I'm going to console log it. I'm initiating a new Roadrunner, and I'm going to console log it. And then to show you that you can actually do the individual ones, I'm also getting a new arms one, because I'm just doing arms, and I'm extending arms base animal. And this shows you that you can use the classes by themselves if necessary. You don't have to have extension after extension after extension. And so I'm going to get new arms. Notice that, however, I have put that in parentheses, and that's because I'm calling a function here, not a class. So how does all this finally end up working? Well, what this ends up doing here is that I'm going to have a cat which has a body, a head, a tail, and legs, and has 4 legs. And I'm going to have a Roadrunner which has a body, a head, a tail, a legs, wings, 2 legs, and 2 wings. And notice nobody has any arms because there are no arms on a cat or a Roadrunner. You want to see how that works? Let's take a look at Node. And let's go to Node function. Sure enough, that's exactly what happened. So now my cat has a base of true, which means I did indeed extend base animals. It has a body of true. It has a head of true. It has a tail of true. And it has 4 legs. It has 4 legs because we told it to have 4 legs. Roadrunner, same thing. Base true, body true, head true, tail true. 2 legs because we told it to have 2 legs, and 2 wings because it have 2 wings. And here's my arms, and this shows you that I can actually extend those individual classes, even though they're not classes or functions, but it's very easy to be able to use those classes by themselves if necessary. So this is a incredibly fantastic way of being able to use a reduce function to simulate multiple extensions. Now, again, I just want to kind of give you the little caveat here, is that this actually does not say, and I'm going to type it in here, class cat extends body, head, tail, legs. No, that's not correct. That's not what it really did. But it kind of, well, actually, even better than that, it'd been this base animal. That's what it actually should have been. is not really doing that in a sense, because it's basically saying, I'm going to build one on top of the other before I finally give it to class. But it simulates it so that if you're somebody who's coming from a language where you can extend multiple classes into a single class, this is a fun and interesting way to be able to accomplish that. So use the reduce method to be able to get multiple extensions onto a single class. And that's all there is to using the reduce method. I hope you enjoyed the video. Hope it didn't bore you to death. Please check out all our videos at www.boringjavascript.com. Subscribe to our YouTube channel or check out everything we have at blog.thevirtuoid.com. Thanks again for watching, and we'll see you later.